Oh, good. Everyone can see my mistakes. Oh, good. Everyone can see my mistakes. Oh, good. Everyone can see my mistakes. Oh, good. Everyone can see my mistakes.
What?
Oh, good. Everyone can see my mistakes.
What?
Oh, good. Everyone can see my mistakes. Echo, echo, echo. Okay, so it was my stream audio on my computer. All right. Okay. Glad that fixed. 10 minutes early. Woohoo, we made it. We're just gonna bum around. We're just gonna bum around until we have, enough viewers to actually I don't know. Actually, I'm looking at the video from the stream myself. It looks pretty good. So, sure. Sure. Yeah. So this dark background, um, the dark background was asked for a long time ago. It was just part of the whole package, but initially you couldn't see snap points. And that's the only enhancement request I have that had actually been gone through. Mhm. Um, so we produce pretty much everything to black, and then within our drawings themselves, we would take specific elements and turn them different colors. For example, all of our lighting, like our in cabinet lighting, is represented by a dashed blue line with a blue arrow to a blue call out that says LGT dash number. Kind of like uh, so let's just give an example. So that would be the line, and then I just pull a leader. I'm sorry if you hear a motorcycle. I don't know why you're hearing a motorcycle, but you're gonna hear a motorcycle. Material. Not my doing. Yeah, that would be, a combination of people, but primarily headed up by Steve Paris, who you'll see on the forums every now and again. He's the boss for me and Toby Sholto. Yeah. So let's just send this to drawing. So we'd send this to drawing, or actually, that would be a little more accurate. So we'd send that to drawing, and of course, you're not seeing anything because I have a whole bunch of stuff hidden. But then within the scene itself, we take this and just take this, and everything else will be black except for that, pretty much. And that's only to call out specifically very specific details. The only other thing we have that's a color other than black is when we do wood grain stuff, like end representing end grain. We turn it to a gray and we send it to the back so that we yeah, it was, and that usually makes it stand out pretty well. Yeah. But you'll occasionally see like examples of my drawings on the forums or something like that. You'll see everything that I'm talking about in there. Um, but when it comes to working in a black background, uh, the majority of our well, the majority of our stuff is, it's going to be some kind of yellow or green or something. It's going to stand out. Um, but yeah, we have all of this stuff are, just custom created symbols that speed stuff up like crazy. Yeah. This is actually for putting lighting on our floor plans. So we just take this and then here. So, but one other thing that's interesting, that I've discovered, if you have grouped CAD, and when you drag out a symbol, it's grouped. Um, this will send everything to black. Yeah, but grouped CAD maintains its color. Well, it is an unintended feature, but we abuse it. Because what we do is we group all of our LED stuff as blue beforehand, or all of our grain stuff when we need to put it on, elevations or floor plans. we group that, and it maintains that grouping. And it maintains the color when you send it to black, so everything goes to black except for what you want. Yeah. But you see how I selected both of them and then attempted to turn them both black? Yeah, that doesn't work. You gotta do them element by element, or you have to do a control A, but then you're turning the blue line you don't want black. And then that's annoying. Uh, I pray to the almighty CV gods that they get live drawings working in a appreciable way. Yeah. Do you want to give it like 5 minutes for more people? Oh wait, no, we got 6 people watching us. Hey everybody. Hey, thanks for having me. I know a bunch of people have already heard me just chatting around, so the official hello. So my goal here isn't as much to do something with doors as it is to explain the thought process behind how to build a UCS in your system that works with the rest of everything that you've already got going on. Those of you that have occasionally seen my UCS list, I have almost 300 of them, and a lot of them are disabled, but there's just a lot of typing there. And interacting UCSs within a mature system can be difficult sometimes, especially if you accidentally overlap parameter names and things like that. You don't want to do it. But right now we're just dealing with, hey, here's some doors. There's some CAD that needs to go with. Here's some doors in a drawer front, and we're going to take and change it to a 5-piece door. So doors. Wait, no, that's 3-inch shaker I want. Sample? Yeah, sample in-house. There we go. So this is just a basic 5-piece door, and let's make it out of white oak plain sliced. That seems like a common thing that people are going to do. Okay, so there's our 5-piece door. This is what we have to deal with. Previously, I wrote down the door style ID, which is something you're going to need, and that's 247. Um, what this one is referencing, I don't actually know. Let's just change that height to 10. Yeah, so it was gonna pull a different door style ID, which means that it's not actually gonna be in this UCS, and this is just a sample. So what you'd have to do is you have to include the smaller door style ID in the UCS so it activates on it. But no, you just got to make sure that it's all in the software. So our primary goals are we need to oversize door parts, and then we need to trim the door, and then I should say correctly. Correctly oversized door parts, trim the door. So I'm just kind of identifying what do I need this UCS to do, and then add door bumpers. Uh, we're just going to focus on left and right bumpers. We're not going to do top and bottom, just to give an example, and then you can obviously just change the hinging and then change which bumpers you want on at that point in time. Um, and let's start with that, and we can add more features if it doesn't run too long. So the first thing we want to do is add an operation that trims our door. Uh, so open UCSs, and now we just kind of wait a second. Hmm. Okay, so when you make a door in house, if you're very very good and very very lucky, you'll be able to make a door the exact size every time, the exact size that you need. But more than likely, that's not going to happen. So, in order to make sure that doors are perfectly square and correct dimensionally, what happens is you oversize the exterior of the door, the left style, the right style, the top rail, the bottom rail, and you oversize it just a little bit so that after you put it together and maybe the slop's taken out and the inside looks good, you take the finished glued up door after it's dried and you run it on your table saw to take the overages out of the outside of the door. And that leaves you a very nice square two dimension face to work with. Uh, Yeah, so what you do is you just take this. Yeah, it's oversizing it, but then you're trimming it down to make it perfectly square on the exterior. Because this could be a little warped, that could be a little warped, and that you can fudge it, but then the exterior is gonna be all wonky if you've cut it to exact size already. Um, Not to mention if you're squaring your door off or trimming it, because both are applicable terms. On your CNC machine, you can add your hinge cup holes in there with it, which naturally come with cabinet vision. Yeah. Oh yeah, no problem. Yeah. So what we're gonna do is we're gonna start out by just adding an operation, and we're gonna want dim route as we trim route dot name. Uh, and I like going things like outline trim. Prime, yeah, because that uh, yeah, because I performance anxiety, and so I'm just gonna copy a bunch of text over here just to speed things up a little. Um, But it is job security because only you will know what you have done. But then 6 months down the line, only God will know what you have done. Okay, so let's walk through what our route is doing. You've seen me delete a few pieces, and I'll go over why that code was in there in a minute. So right now, we have a route that is the exact size of our door. It's on the exterior of the operation, and so if we look at the rcut value, so let's go function F1. So let's just keep this open for a while. UCS's system parameters. So whenever you're yeah, sure. Talk for them for a second. Uh-oh. Hmm. Uh-oh. Yeah. Yep. And then pop back in at some point. All right. So one of the first things that I do whenever I'm writing a UCS for something specific is I pop into the help files and I see what system parameters already exist there. So as you see, I'm making a route for an outline trim on the door. So I'm just going to cycle through it and I'm going to look. Okay, so MDF route. This isn't an MDF door maker thing, so I don't want a pocket operation because that would obliterate the door. So here it is, R cut. So we want the type of path used in a route operation. So we can have a center, an inside, an outside, or an outside door route. As it turns out, an outside door route cuts on the inside of the line, which is something that I discovered not too long ago, and I've been doing this for a long, long time. All I've needed so far is the outside cut. So we want R cut 2. Now, if you're trying to do curved cuts, our cut tends to flip it one side to the other, um, depending on the amount of curves and the shape and all this other stuff. So be careful if you're doing a curved operation. Test the heck out of that thing in simulation, which you'll see in a second. But in this case, we're just dealing with a square door. R cut 2 is going to work. Is there anything else? This is not on a door maker template. And then we're back up to max T-red.
Just a second. Sorry, guys, if you're
Oh,
seeing
yeah.
my cabinet vision. Go ahead.
They are.
Should be. You're good, David. You're back up. I just had to move it out of the way.
Ah, there you are. Haha.
So,
Oh,
sorry
so
for
my
the
rubber
interruption,
duck,
real quick.
Quack. All right, or squeaka.
All right. Sorry about that. Carry on.
All right. No, totally fine. So we've looked up the stuff for routes that we might need, and we need R cut, and we need face work plane because we want to cut our doors face up, or at least I do. So face work plane is one, and then we've got an operation that is around the perimeter of the door and the depth of the door. And then it's on the outside of that operation. And the tool ID 116 is specifically the tool that I'm going to be using to cut 3/4 inch to 1.5 inch solid stock, depending on the thickness of the door.
Why do we want this to be on face working plane 1?
Uh, if you have a raised panel door or a door with molding on it, you don't want it cutting from the backside because then the door will be sitting on the molding and you'll get blowout on the face.
Perfect.
Typically, you don't have something sticking out the backside of your door. Typically, I make no promises because the second I say, guaranteed nothing sticks out the backside of the door, someone comes in with something that proves me wrong. So, yes, we've got that. And now we wait a second because now we have every door and drawer part in our entire system is now getting this route.
Excellent.
does not help us much. So step 2 is to filter it out to just the doors we need.
So, speaking of,
Hmm.
do you tend to have, I mean, for the most part so far, this I feel like could be applied to any doors that you're making, but do you feel that you need to have different UCSs for different door setups, or can you capture everything pretty much in one?
I think you can capture just about everything in one, with one caveat. I have not tested this on miter doors because we don't really make them here.
Okay, I gotcha.
Um, so, so what we want to do now is we want to use the. Whoa! Something just closed down over here. There we go. Okay, sorry.
Totally fine.
Face, drawer opening, drawer box, drawer object, and then there's our outline trim right there. So we know it's there. DX is not evaluated, and then its test condition is there, and great. So everything looks like it's working fine there. And okay, so let's take a look at this in 3D. Sure, okay. Something looks a little off. And that little off could be the fact that the materials for the door itself are kind of wonky. It could be a 3/4 inch thick flat panel inside of a door that's got 3/4 inch stiles and rails. There was a graphical glitch that was going on with this operation where it'll hide the left stile.
Hmm.
And for some reason it's actually not functioning that way now. Kind of wondering why. Regardless.
Yeah.
Let's just check something real quick here. Yes. And yeah, there we go. Oops. Material schedules. And this was 0750 White Oak. Plain, either rift or plain slice, either or. I'll just check them. So what I'm going to do is I'm going to double check and make sure that the panel itself is like 1/2 inch thick or something.
Gotcha.
So door. Again, this is one of those things. We're dealing with a mature system.
Man.
So
I need to not complain. I don't have that many to manage.
yeah, it's fun.
How many of those do you use, do you think?
Well, they're all here because they've been used.
Right. But
Yeah,
like,
we make them as we go.
yeah. I guess you have to, right? There's really no
Yeah,
other way.
I mean, originally I tried just creating a template like here's solid stock 1 for this job, here's solid stock 2 for this job, but it just created too much confusion out in the shop.
I gotcha.
And so you'd have this one going to the Strand, but the Strand was White Oak, and then this one going to Santa Barbara, and it was Walnut or something, and we'd get the doors swapped or things like that.
I gotcha.
So for clarity out in the shop, it's better to just have your system be what the shop is going to be using. So utilities, update job. Hey, if you want to give your introductory spiel again, go ahead.
Yeah, well, I kind of just typed it up, so whatever.
Oh, okay. All right. So let's take a look at this in 3D. Okay, so now we're seeing what we expect to see, where it's a recessed flat panel door, because I change things on the fly for things all the time. So now, if we took this to the S2M Center, if we took this job to the S2M Center, which is another reason we're doing this on 11, by the way, because it goes to the S2M Center really fast.
Excellent.
So sample in-house door is a part generated by Cabinet Vision If you go to the splash screen, you go to the S2M settings, and you can see something. There's an option there that says, let's actually just go there. There's an option that says incorporate door operations into a slab door part for your CNC machine. Preferences, geometry, incorporate door assembly operations on slab door part for CNC. So this will take a 5-piece door or any multi-piece door that you have and take all of the operations. For most systems, that's just going to be hinge holes, but we're kind of taking this feature and doing more with it. And then putting that into a slab door part that the name of the part is going to be the door style.
Okay.
And then that gives you the ability to, let's say, abuse it, but really it's a feature that they planned for you to be able to do stuff like this with.
So would it be accurate to say basically what that checkbox is kind of doing is,
well, it's generating this part.
Yeah, it's creating something that otherwise wouldn't even really be there.
Yes. And so what we've got right now is we've got a door and we've got mounting holes on the back of the drawer front in this particular case because it's a slab and it's a little hard to see those operations, but they're right there. And then that's just an indicator hole that says this is the top of the drawer.
Familiar with that one.
But if we sort this, you'll see the other in-house doors as well. And in this particular case, you can see the hinge holes. And if we edit the operations, we go to the back, and here's the operations coming off of your hinge hardware from your hardware catalog.
Gotcha.
Now, if we go no machine, because this is not being a nested material, this is just a secondary operation. And we take a look at it, here it is. And if we go to the machining simulation, which is going to pop up over here, it'll cut the hinge holes. And if this behaves the way it did when I originally wrote this kind of system in version 9, oh, you see it's actually trimming it.
Yeah.
And you can see the trim operation happening. So this was not the case in version 9. In version 9, if it was outside... Oh, actually, hold on. It might be that I have that...
Ignore operations thing.
Yeah, so... tool warnings, geometry...
No.
No, okay, so...
Fourth from the bottom.
1, 2, 3. Yeah. Ignore operations outside of parts nest boundary. If you have that checked, so let's do that. So you just saw that it trimmed that door. Now I expect it to ignore that outline operation. So let's just speed this up a little bit. Oh, wow, no, it still did it. Okay, so in 9, that would not work. And what I had to do is I had to move the operation in 1/1000th of an inch.
I gotcha.
Because, you breathe on a piece of wood and it moves more than 1/1000th of an inch. But, yeah, so, hey, guess what? I learned something new.
No, that's good. I was actually going to say that is an unfortunate sort of like requirement, because sometimes you literally want to ignore that. I mean, that's a feature that is there for a reason, but no, that's really good. That's good to see that it works that way.
Yeah, so it actually works. If it's dead on the part, it'll work. Nice.
Awesome.
So I guess that was something that was like an internal bug or something that they fixed. Which also means that there was a graphical glitch that used to occur because you had an operation that was 1/1000th of an inch in that would make this style disappear. And now that's not the case. But still, one of the things you're going to want to do here is hide that operation, because it could show up at weird points in time, and you don't want it showing up in your drawings. Everything about this UCS is going to be hidden. You're only really going to see evidence of it when you optimize and in the object tree. and in your part lists. So we're gotta wait a second. You guys have any questions? Listening
Right?
to us ramble on? Uh, so what I would do is route dot underscore hide equals 7. The hide parameter is interesting. It works fun ways. So if we come here, Control F, hide. Okay, let's go underscore hide. So if you have a value of 1, it hides in plan, 2 in elevation, 4 in perspective. If you want to hide it in plan and elevation, you give it a hide value of 3 because 1 plus 2 is 3.
Mhm.
And if you want to hide it in plan and perspective, but want it to show up in elevation, like say you're doing V grooves on doors or something, which can add a lot of little lines if you're sending something from a floor plan view. Uh, so you'd want to hide it in plan and maybe in perspective for whatever reason. So you just give it a value of 5. Um, but in our case, we want to hide it everywhere. So we're just going to give this a value of 7 because it's 1 plus 2 is 3, 3 plus 4 is 7, and now I've given you a basic math tutorial.
I've always really liked that. I think it's a really clever way that they do that.
Yeah.
I've wondered if there's other ways that that could be utilized. I just don't have the brain power
Oh,
for it.
absolutely. I'm trying to remember the best example I had of that. I wrote a UCS at one point that did something based on that.
Very cool.
Like, if you wanted conformats on an edge, this was back before we had drop-down lists.
Mm-hmm.
So if you wanted conformats on an edge, and you wanted dowels on an edge, and you wanted like mini fixes on an edge or something, you could put in a value for that edge in my edge selection UCS, and it would look at the interpretation of that. But now we have drop downs, which is 1,000 times more efficient.
Yeah.
And yes. Oh wait. Cancel. No. No. Yes. Save the changes. Now I have to go back into it because I forgot that we needed to do more here. So right now, this is happening on every single drawer front in the entire system, and we're on a network, so that's hundreds of drawer and door fronts, and a lot of them are buyouts and slabs, which don't need it.
Mm-hmm.
So we need to restrict this specifically to our in-house doors. So if. And I'm just going to go door style ID does not equal 247, then exit. And then don't forget to end if. So now it's only going to operate on the one door we're working on. And that's pretty standard. So you want to start out by doing something, testing, making sure it works. So we know it works, and we did it and we tested it. And now we want to make sure it only applies to what we want it to apply to. So that would be our filter there. And that's the trim. And then now we have door bumpers. And we want to add those. So we're going to start with whenever you turn something on, you want to make sure you can turn it off. When you want to have something perpetually on, you want to make sure you can turn it off. So if door bumper me equals null, then this is basically the only time in which I actually use null. I don't really test for null in any other position. If something is false, it's going to be equal to 0. If I have something that needs to be equal to 0 and I want to shut it off, I test for a -1 instead. And I'll show you an example of that later.
Okay.
Then door view bumper me Boolean
Oops, sorry about that.
That's fine.
I'm kind of trying to. I want to follow a little bit along, so sorry if you guys are seeing things flashing. I'm just moving them over to my other screen.
So now door bumper me instead of Boolean, we want style. So actually, no, this needs to be a cabinet level parameter. So what we're going to do,
Okay.
0, then sorry.
No, you're,
You
you're
also
totally
need
good,
to
man.
consider where your on-off switches need to be. In this particular case, doors don't really store all that many parameters all that well, at least in my experience. But then my experience is old and outdated, as we just saw. So it might be that its doors are just fine. But this will be a cabinet level parameter, door bumper me, and it could be job, whatever. We're not going to add it to the system. We're just going to add it to the individual cabinets.
Mm-hmm.
And then we're just going to go on and create a VBOR. So in this particular case, we're going to start with our drawers. And this is just code for the drawer.
Mm-hmm.
Now, if you notice, there's a parameter in there that it's referencing that we haven't made yet. I'm doing this because it's easier to read.
Thank you.
So it's going to reference bump on holes offset. So I'm just going to rename that bumper offset because I don't want it conflicting with the UCS that I already have in my system. So if bumper offset, actually, these are all on the door itself. So yes, it'll stick. What am I doing? Okay, so if door bumper me equals no, so I can do this too here too. I'm being a fool. My apologies.
You're totally fine, man. This is complicated stuff. It's even harder to teach than it is to do.
Yeah, you're probably right about that. Tab. Door bumper me. Boolean. So a Boolean is obviously just a true-false variable. Most of you guys know that. Style. I almost always use attributes. I can't actually remember a time in which I actually used notes, but that's just because I'm not someone that does a whole lot of the really complicated stuff like Jonah's millwork walls.
Mm-hmm.
If something like that happens to me, it's in it's going to be a one-off, so I just do it there.
I gotcha.
And that's just what I'm doing. Someone that does a lot more commercial stuff probably has more use for that than me. Style and then description. Door bumpers? Question mark. So there it is. And then if door bumper me equals 0 or equals 0. Oops. The numpad enter is not the equal sign. So then we're putting a parameter on it and then checking and seeing if the parameter exists. And we're also doing bumper offset here. So then so whatever we create down here, when we turn off the UCS, we want all of those parameters gone. So as I create custom parameters beneath this exit symbol, or beneath the exit statement, I'm going to add deleting them above. That way it resets the system and it doesn't clog you. Not to mention, if you turn it back on later, you're reset to default as opposed to needing to remember that you've already made the change.
Right.
Now, getting rid of that delete statement would preserve it in between turning that UCS on and off.
Which depending on your preference, I could see value in both, to be honest.
Yeah, there is. There absolutely is, because sometimes you want it preserved one state to the next.
Mm-hmm.
So when you create a parameter, its default is measurement, except for specific named parameters within within UCSs, like name. I don't have to call out name as text, uh, but the vast majority of them, you're going to want to declare what kind of parameter it is. The
Mm-hmm.
exception being anything that's a default measurement. So I could technically remove this, but I put it in there because of force of habit. Style equals 1, and so then bumper offset description, bumper offset, and then end if. So now we have an attribute that's set to 0.375. Now the reason we do 3/4 of an inch is because your typical internal part's going to be 3/4 of an inch thick, or 19 millimeters if you're, communist. Sorry, had to do that.
No, it's fine.
But in reality, our typical reveal is also an eighth of an inch, or 3 millimeters. So we want to subtract about half that value. So it's really going to be 0.31 ish. I'm just going to go 0.3. So our bumper is going to be 0.3 inches in from every edge of the door. And in the case of our drawer, it's going to be this. So what we have here is we have a DX of 5 millimeters, because our bumpers are made by communists. Sorry, this is going to be a thing. And we have one of those knock-in bumpers. So a bunch of people use sticky bumpers and they just slap it on and that's the end of it. But we feel like they have a tendency to fall off, which, let's face it, they do. It's adhesive.
They do.
So we use little barbed bumpers that go into a 5 millimeter hole, and this is what we use to apply them.
Okay.
And I think they're about the same cost too. So it's like, if you've got a CNC machine, you're throwing your doors on the CNC machine. This is actually just better in
No,
general.
I like it a lot. I like what you're talking about. It creates consistency, and I mean,
Well,
honestly, those sticky things always fall off.
yeah, exactly. And so it's just a better product.
Yeah.
But you have to drill those holes, otherwise you don't get your door bumper. And then you have to make sure to not drill those holes when you don't want them, because then you have holes in the backside of your door, no bumper in it, and it's not contacting anything. And that gets awkward quick.
Yeah, I'm sure.
So our Y position is going to be middle of the drawer front. And then these are the rotation values to get them lying flat across the width of the drawer. And if we hit close here, so that's another thing. When you're doing a UCS, you want to periodically close the UCS, look at what it's doing to your system, and then correct if you need it.
Very, very good suggestion. I think that's a really try. You just check. Basically, right? That's like the plan, do, check, act sort of loop, right? You're planning, you're doing just a little bit, you're checking it, and then you're acting on what you see. I think it's a really good idea.
Yeah. So as you can see here, we've got our mounting holes, which are horribly placed for this particular front, because that's dead on right there. That's bad.
Yeah.
That's terrible, as a matter of fact. but that's what we're after right there, that 5 millimeter door bumper hole.
Okay.
And let's take a look and see if I remembered to name it something or if it's just hole. I
Even
didn't
better.
name it anything.
It's just null. Nice.
Yeah, lovely. So this is why you go back and you check. So we know our door bumpers are working. We could go and check in the SOM center, but I'm reasonably certain that they're going to turn out okay because they're a 5 millimeter hole that's 9 millimeters deep. And let's face it, if a CNC machine is good at doing something, it should be good at drilling a 5 millimeter hole.
I would agree, and I would also say that honestly, as much of what we're going through today, this is all hypothetical, and anybody taking what you learned today and applying it should be testing and testing and testing again and again with this. As is always the case, right? You're dealing with a very, very expensive piece of equipment, and if you're trying to get it to do something new, test.
Yeah, run it through simulations. Look at the code for a Z breach. Although Cabinet Vision actually now, I think it was new for 11, where they had a maximum Z breach value that you could put in. I have mine set 1/8 of an inch.
Yeah, that's a good idea.
Yeah, it's a fantastic feature, especially if you have people that do things like manually change the DZs of materials.
Yeah, let's not even go down there.
So, whoops, almost forgot the equal sign there. That would have been awkward. VB drawer name drawer bumper. So now that'll show up on the description for it. And now this is appearing on. So if we close this down and we take a look. Again, we're now going to need to filter stuff again, if I don't miss my guess. Any questions out there, guys?
I actually wanted to take just a second to kind of like, in case anybody is joining, I'm not really paying attention to the number of people on the channel, but if you happen to be joining us, so far what we've managed to do is David has built a simple UCS right now that is targeting specific doors and applying specific operations. That's basically just about where we are right at this point. So go ahead, David.
All right. So we have our holes, and they're on our drawer front, and it's perfect. Except that's not great on our doors.
No, it isn't.
No, it's not. So we have to filter it out so we, again, make sure that it applies only to the parts we want it to. So back into the UCS we go.
Something kind of interesting about this, I've never really explored doing what you're doing right now, to be completely honest. I mean, I do with slab doors, but that's pretty straightforward, right? An interesting thing about this is you're actually not adding operations to stiles and rails. You're not adding operations to the individual parts, but they are still getting them. I think
the individual parts are not getting them.
Right, but like visually, everything about it behaves as if they are. Yeah.
Yes. It's the overall assembly that's getting the operation.
And this is such a this is a far simpler way to do it versus targeting those individual parts. This is very clever. I like it.
Okay, thank you.
Yeah.
So this is going to be one of the first instances I'm going to talk about of else. So we only have two options here because of our for each statement, which is door and drawer part. We want all of this stuff to apply to everything from here up. We want it to apply to both doors and drawers. but we want it to only apply to this specific style of door. But now we want just this to apply to drawers. Well, the only other thing is doors. So what we're going to do is we're going to separate the code with an else statement. Now I could go if drawer then end if, and then also do another if door then end if statement. I could write it like that. I could do and that's perfectly valid, but overall it runs slower. The else statement just makes it more efficient, but a little harder to keep track of. So one of the common things to do is in an else statement and an end if statement, frankly, is to put this, if they're separated, the if statement within within that line.
That's a good call.
And then that way you know what this is associated with. Now, that doesn't always work if you have an if statement that's, 300 character or 200 characters long, which I've definitely had before.
Mm-hmm.
Then I just go, this was really long. See line, blah, blah, blah. And then that leaves me a way to track it all. So we've got our holes on our drawers, and now we need holes on our doors. Okay, so we have, for our doors, we're just going to deal with left hand and right hand doors. So we need to know what hinge values we're dealing with. So we need the hinge parameter. Control F, H, and G. And obviously hinge character is not what we're after. And then hinge part, door open amount. Here it is, hinge. Specifies hinging on a door or drawer. So none, left, right, top, bottom. So normally where I would see a hinge of 0 would be on a trash pullout or something along those lines, where it's a pullout hardware of some kind.
Mm-hmm.
And you can, for those, you might want to add a bumper in each corner, all 4 corners. Makes sense, right? But in this case, we're just going to deal with hinge 1 and hinge 2. Just left and right hands. So if hinge equals 1, and in this case it's actually colon hinge because it applies to face opening. And if we go into the parent of, I just closed that. Function F1. I hate doing that.
Mm-hmm. Seems like every part of cabin division teaches us patience, doesn't it?
Well, in this particular case, it's just my own thing. Oh, I'm done with the window. Let's close it. So it applies to the face opening. And the parent of the parent of the door part is the door opening, and that's where the hinge value is stored. So if hinge equals 1, then, and we're going to want to dim here, and then dx minus bumper offset. I'm just gonna minus bumper offset minus bumper offset. So we just go the length of our door and the width of our door and drop a bumper in there. And simple as that. And then we do it again. gross. I'm replacing all of these custom parameters that are within my system to begin with just a simple version of it. So now we have our line boring. This is up in the top corner of the door. This is in the bottom corner of the door. And these are all the orientations and sizes and everything for that. And you can copy a lot of that code from what's here to begin with. We just don't have a repeat 2 or a spacing. Technically speaking, we could do a repeat 2 in spacing, and maybe that'll speed it up a little bit more.
Mhm.
But I'm just doing with 2 individual operations.
So something here I'm seeing, and
Mhm.
correct me if I'm wrong. You need to have those 2 operations named differently, right?
Well, they're not named right now.
Well, I mean, like the way you're actually calling them, the vbor_lh, or are you?
No, because you're closing. Dim. As new line bore. So no, because you're starting over once you add a new dim statement.
Okay.
So no, you don't need to name them something else. At least not as far as I know.
I think this is an area of the software that I don't know if version changes have changed how it
No,
works,
you don't.
or if I've just like really never really fully understood it. But carry on.
Okay. vbor lh name bumper top right, because it's in the top right, although technically it's a left-handed door. And then bottom right. And this tedious process here.
So as long as we're just talking about like little tips and tricks and stuff, which I think is a good thing for us to share on these types of streams, did you know you can highlight an entire block of code and tab and get it all to tab at the same time?
Let's see if that works in 11. Oh, crud.
Yeah.
Did not know that. Ooh, yes.
That's a good time saver. I wish they still had the control drag select.
Yeah,
thing,
the control drag is what I was used to, and I was pissed when it was taken out.
Yeah, it was a really frustrating thing. Switching over to that sort of highlighting and pressing tab thing is.
Well, the thing is that, yeah, so it doesn't work with
No, sir,
and
it does not.
So the control click drag was great for commenting blocks of code.
Mm-hmm.
And these days, I just have Notepad plus open, and I'm copying and pasting blocks of code.
Yeah, it's annoying.
Yeah, it is. Yes, save the changes. So now what we should see is on one of our doors, and I just made a mistake, and I just realized it, and it's going to take a while to fix. Can you see my mistake?
No.
We have an if hinge equals 1 and no end if.
Well, you got one. Oh, never mind. That's not for the.
Yeah,
that's
right the end if for the drawing.
Unexpected end of UCS. There we go.
Oh, pain, anguish, humiliation galore. I feel like Prince Humperdinck.
No, I am distracting the crap out of you. I know that to be true.
Regardless, I've done it 1,000 times regardless. Makes no difference. I will screw it up somehow. As will just about everybody. And I have more than a decade coding UCSs. Let's put it that way, just to make me feel really old. And that's just life. You're gonna screw it up constantly. You're gonna make little errors here and there, and you just gotta not let it drag you down. Yeah, actually, and if we want it there, extra space, and then there. Now we know that we've end-diffed the hinge. So now we should have our holes back and our trim, and it should be glorious, right?
Excellent.
We are evil scientists doing wicked things. Oh no, Tristan called me on it.
He did. He did.
Uh,
He is a sharp dude.
Yeah, I forget to put a then at the end of an if line too. I don't think you need a then on standard like Visual Basic coding, right?
You don't, and it's so hard to try to learn other languages after learning UCS first.
Okay, so this is interesting. We've lost our drawer holes, but we have our door. I wonder what happened.
Something with your filter, it looks like.
Probably. Back into the UCS we go. And while we're sitting here, what's your favorite Disney movie?
Oh my god. What's my favorite Disney movie? That's really hard because I don't like watch anything. So the only things I can even pull from are from my childhood, and
Yeah.
Disney is so different today.
Yeah. Well, pull it from your childhood.
The Rescuers Down Under.
That is a great one. I love McLeach as the villain.
Yeah, that was a fun one.
So, if name drawer. So, why is it doing this?
I think Tristan got you on this one too.
Did he?
Quotes around drawer.
He might be very, very right.
I think he is. So next week we'll have Tristan on.
Yes, humiliating the crap out of me.
Yeah, I think up on line 42, if you capture drawer in quotes, it should work.
Okay, you are probably very correct. Wait, did Tristan say that? I don't.
He did.
Oh yeah. Oh yeah, he did.
He did a bit further up.
Oh man, and I'm the expert.
Yeah, there we are.
I'm the guy you called in to show. Hey, this is how you do it.
That's all right.
So guys, don't feel bad. And yeah, Tristan, you're probably 100% correct. And yeah, there we go. Yay, Tristan!
Perfect.
The peanut gallery does something useful. Yeah. See, I haven't had to write a filter for a name of something in so long. I've forgotten it.
Mm-hmm.
So we've got our drawer, and we've got our left-hand door, and now we need our right-hand door. And can you guess what we might need to do for our right-hand door?
I can guess. I'm not gonna steal your thunder though.
No. I'm asking if you can guess.
So I would filter this based on the hinge, you know? Right?
Yeah. Okay.
Instead of one. What's going on here? I think we might have dropped.
Oh, yeah, we did. Okay, so real quick, let's restart that. Chrome remote support. Okay, generate code. Let me know when you're ready.
Ready.
55, 88, 76, 43, 22, 75.
All right, we are.
Do you have to reset it where you're back to one screen again?
Yeah, but we're good now. We are back.
Woo!
All right.
Sorry about that interruption, guys. And we are back into UCSs. Yes, here we are. So let's reopen this UCS. And so now we have all of this code we've done for the left-hand hinge. So let's just copy it all.
Definitely.
And the reason I'm not going else here is because there are many other hinge values that we're dealing with. In this particular case, 0, 1, 2, 3, and 4. So an else statement wouldn't work here because we don't have a binary selection.
Yeah.
So hinge 2, if hinge 2, and then I'm going to do a find and replace of. So Control H is the hotkey for find and replace.
Super
And-
useful tool.
Yeah. And replace. Yes.
Uh-oh.
No. It just blinked it. That's all.
Mm.
Wait. Oh no.
Oh no.
Okay. Control Z. Oh no. I have to undo it all.
Mm-hmm.
Okay.
Interesting.
Whoops. Okay, so hinge 2.
So that was a spectacular example of how find and replace is the best and worst thing ever.
Yeah.
Be careful using it, guys. What happened there, if you didn't catch it, was rather than specifying a set block, which you can do, there's like an in selection option, or going individually, we did the replace all, and we definitely don't want that.
Here, come look at me make all the mistakes so you don't have to.
Well, I mean, honestly, it's a really good lesson to learn, and better, frankly, better for you to do it here.
Yeah, it is. No, and again, it leaves people with the idea of if this guy's doing this and he's considered an expert and he makes this many mistakes, then there's not really any issue with me going and doing it.
Yeah,
Because UCSs can be very intimidating.
they are.
Yeah. So now we have hinges on the left-hand side. So how do you move something from the right to the left? Well, you move it back the width of the part. So that's back the width of the part, and this is back the width of the part. So this is at the top, and this is at the bottom, and now they're on the left-hand side of the door, which is what you want for a right-hand hinge. And now let's see if I've remembered my end ifs.
I think you got it this time.
Yeah, I might have. And there we have it. So now that we've coded all of these operations into it, let's take a look at them in the S2M Center. Just to make sure that everything is cutting correctly. So sample in-house door, output CNC ops, just pick one, and machining simulation. And here we are. Let's actually stop and let's start it over so you guys can see it all. So there's our 5mm, there's our 8s, there's our hinge cups, and then it's squaring off the door. Now, the next step, so we added bumpers, and we're trimming the door, and one of the other things we have to do is correctly oversize the door parts. So normally when someone's being given a list of stuff from Cabinet Vision, like you can get a programmed list of styles and rails and a board stock cut list. That's a common occurrence. Reports and report center and door. And here's a, well, okay, that's an overall door cut list, but here's a door checklist. And it gives you 3 by 1/4 inch, and let's actually zoom in here. Single and pair doors. So I'm just gonna screenshot this so we have it for reference later. We're just gonna look at one of the doors and just haul this off to the side. So we got a screenshot of it hauling it off to the side. But if you notice, we've got 3-inch stiles and rails, and it's 10 by 20 and 1/8. And that's going to come into play. So you can hand that to the shop, and the shop can go, oh, I know that this is an exterior part on a door, and so I need to oversize it by a little bit. Or you can just not trust them to know that, because that's what happens. And you can tell them, no, I want you to cut it a 1/16 over by adding the 1/16 of an inch to it. So let's go back to our UCSs. And this is where things get hidden. So we've added our operations in one complete UCS. And now we're going to add our oversize for door parts in another. And our door parts are the door top rail, the door bottom rail, the door left style, and the door right style. So DTR, DBR, DLS, DRS. And this is the same whether or not it's a door or a drawer front. So take that for what it is. Take that for whatever it is you will. So let's come to another UCS that I've set it up. So door top rail, door bottom rail, door left style, door right style. And the reason we're not including door mid style and door mid rail is because they don't touch the exterior of the door. So for a standard 5-piece door, frame and panel door, like what we're looking at here, you have this top and bottom rail is running in between the left style and the right style. So we need to increase the width of this part, but not the length. And on the left and right style, we need to increase the length of the part and the width. So if name equals single quotes now, DTR. Actually, no. We want EDX because we want the width on all 4 parts to change. EDX equals 0.625. No, 625. Sorry. 0.625 would be a little much. So the width on all 4 parts is now changed by a 1/16 of an inch. So this is pushed this way, this is pushed this way, this is pushed this way, this is pushed this way. And now, if name equals, I will not fat finger the wrong key now, DLS or name equals DRS. So if it's a right style or a left style, then EDY equals, and the immediate impulse is to say a 1/16 of an inch here, because that's the adjustment for the width. But it's actually an 1/8 of an inch, 0.125. And the reason is because you have to make the adjustment twice. You have to go up a 1/16 and you have to go down a 1/16 on both of them. One other way to write this UCS would be public, if you want public parameters, but I don't. So door oversize equals 0.0625. 0.0625. And then EDX would equal door oversize. And then EDY would equal door oversize times 2. And that gives you the exact same thing. But this is an example of writing a parameter, referencing it later, and using it to symmetrically control your door. So if you wanted to change this to, if, for example, you had a shop that worked in millimeters, 1 millimeter instead. And so it would oversize your doors by a single millimeter. But in our case, we're not communists. And I'm sorry, that joke is just never going to pass my brain, ever. Close. Brandon, I can't tell if you're talking to me.
I was not.
Okay, good. You just hadn't said anything in a while, so.
No, I'm just observing, just
Okay.
kind of observing and typing a little bit, and kind of following
Right.
along some. One thing I did want to say is that for anybody who is here specifically for the UCS writing aspect of what we're doing, I for whatever authority I have on this, I really agree with what David was showing there about sort of establishing a variable early on and then referencing it later in the UCS by establishing the door oversized value. And a lot of it really is for exactly what he just showed, right? If you want to write a UCS that can be shared with the broadest possible audience, establishing it the way that he showed really makes it a more flexible UCS, because every shop is going to be different. Every shop is going to have different requirements, and changing that value one time at the very, very top is so much easier to manage if you want to share what you're writing with others. It's a really, really good practice, and it's not super hard to do, but you do have to be intentional about it. I find that I have to kind of go back to my UCSs after I've finished working them and update them to be more in line with that sort of like theory.
I done goofed again.
Yeah, it's all right, man. What is it this time, I wonder?
No, it's another NDiff. I forgot to close the NDiff for the oversized UCS. But just to let you know, the EDX and the EDY parameters, again, they're just system parameters. They're not something custom that I made. And you can see what they do right here. They adjust a part, specifies the adjustment to the whatever value, in this case, the DX, but the DY applies the same way. Does not apply to CNC output and only to cut lists, which is what we want, because we're not cutting our styles and rails on a CNC machine. Now, you might want to, but we're not doing that here. So if then, and if, and just for practice. And this should theoretically work. I'm like, you guys can't see it, but I'm kind of mumbo jumboing, waving my fingers at the screen. Make magic happen. Anything to keep yourself entertained while you're coding. Right. Okay, so now, as the parameter said, you will not see this. It doesn't exist until you go to your reports. You go to Report Center. You go to your door checklist. And let's zoom in here. And
very nice.
Here's our reference. Save report. Hinge plates obviously don't change. The door flat panel, 9 3/4 by 15, 9 3/4 by 15, exactly the same. The right style, 3 by 20 1/8, 3 1/16 by 20 1/4. There you go. Perfect. And it's doing the 16th over size, and the top and bottom rails only got the adjustment to the width, which is exactly what we want. So there you go.
Beautiful.
So now we have we have this. It's done, right? I
Mm,
mean, okay. Well, what would you add?
I'm not necessarily suggesting that I would add anything. I am just wondering about taking the door once it's made and placing it on the CNC, which I'm sure you're going to get to.
Okay,
Um, but I don't know the we're totally done, but we might very well be.
we're not. So one of the common problems that occurs out in the shop is how do you associate this blank box, which is what that is,
Mm-hmm.
with with an assembled 5-piece door without measuring 1,000 of them. Not to mention compensating for the oversized dimension, because this is the finished size. The door size is 14 and 7/8 by 20 and an eighth.
Mm-hmm.
And you're going to be getting doors that are oversized by 1/8 of an inch. So you're going to be measuring something that's 15 by 20 and a quarter. But then you have to keep that in mind, and it gets a little scattered.
Yeah, it could be very confusing to deal with. I can see a lot of mistakes being made.
So what you want to do, and so this is your secondary optimization printout.
Mm-hmm.
Let's just full screen this thing. This is what you will hand your guys in the shop. Cabinet Vision has something called labels. If you enter section editor and you see it's 1A here, 1BL, 1BR, and it's tied to a specific cabinet, in this case, cabinet number 1. You can use this to specifically target doors and parts and drawer pieces. For example, one of my UCSs, one of my favorite UCSs that I've ever written, adds the label to your drawer parts.
It's a good one.
So the shop gets this view sent to them. And so they know 1A is this drawer. And so they build the drawer, they stick it in that slot, and they know that these drilled holes for fastening will fit that drawer. And there's no guessing. There's no fussing around with putting one drawer into another slot and kind of getting it right. It's like 1A goes here, 1B goes there, 1C goes there, 1D goes there. And you've got it. It's done. And then that also lets recuts happen much simpler because you go, okay, I need the left side of drawer 1A on cabinet 1 instead of its drawer side is what Cabinet Vision gives you. They don't even differentiate between right and left. So it's one of the drawer sides on cabinet 1. And you could have 6 drawers in there. And you could go by size, but then there could be 6 of them. 6 drawers all with all the same drawer side height. And so you have no idea which one you're actually dealing with. So renaming your parts and adding the label to it is one of the best UCSs that you can have for saving time in the shop and giving yourself less of a headache when dealing with stuff from the shop as far as recuts and anything else.
Very good advice.
So what I've done a long time ago is written something that will take the label parameter which exists on the door and shove it up the object tree for reference later.
Okay.
So one of the things that we don't have though is the ability to just take that into take that directly into the S2M center.
Mm-hmm.
So let me see. So this is label to opening. Very simple. For each door open, drawer open, you store the label parameter.
Okay.
And then that's only really useful for drawer parts for what we're talking about because your D box contains the individual drawers while this is the drawer face.
Mm-hmm.
you could technically dig in the object tree and find the label, but this is much simpler. So this is the UCS block that we would use. If name door, then add a comment, door label. And so the comment is a field that we can bring into a report to reference.
Perfect.
And it's a common field. It's already in existence, and it's going to require a little bit of an SQL statement. And I actually didn't know how to do this until you posted your videos.
Good. Did some good in the world.
Oh, yeah. So what we want to do is we want to go to the S2M Center, and we want to go to the reports there. And I'm kind of showing you what I did in this particular case. So sample in-house door, output CNC ops. Cancel. Come on, highlight it. Output CNC ops. Run. Okay. And reports. And we're going to go set up reports. And I want part printout legacy. Design report. And anyone that's following Branded this should look a little familiar to them. So, sorry, go ahead.
Nothing. Go ahead.
I've actually forgotten a bit on how to do this.
Quite all right.
Where do I find the select statement to import fields into the report?
That will be in the report properties, not the design.
Okay. Whoops. So here, properties. Yeah, here it is. So one of the things we had to do was include parts, SQL.
Oy.
Now, a lot of this was just its thing, but select parts.comment. You had to add this in here. That's it.
Yeah, sounds about right.
That's it. You add parts.comment in there from assemblies or from no, that's assemblies number. So parts.comment. And then that gives you the ability to reference that field later
in the design.
Design. And what I did was I edited this field here. And part information. Oh, that's the border. There's the part information. And contents. And I was able to include, because it had just had part name, part size, part location, material name, and I added part comment by kind of copying the what was going on here and just putting it there. And so you'll see, excuse me, don't save the changes because it already works and I know that. So here's the part and sample in-house door 1BL. Beautiful. And then cabinet number 1.
Beautiful.
So when the guy builds it in the shop, he just slaps a Post-it or something, or a piece of tape or something that says, "This is door 1BL for cabinet 1." And then the guy at the CNC machine doesn't even have to think about it. He just takes it, throws it up on the CNC machine, face down in this particular case, because we want to drill hinges. So yeah, actually, I don't know how we're going to do hinge boring on a door that is face down. So if you have applied molding on a door, you're going to need to space it up and probably just with a piece of MDF on the panel to suck it down tight. We don't really do a whole lot of applied molding doors here. So anyways, and then offset the Z-axis of your CNC machine. So now you have one other difficulty to run into, and this is where your shop actually needs training. if we look at the machining simulation, so what's happening here is that it's trimming directly on the 0, 0 point of your machine right there.
Mm-hmm.
That is the 0, 0 point of my machine. But my door is oversized, which means that the door naturally sits a 16th of an inch in on the x-axis and on the y-axis. So the thing you have to do is you have to change your machine's 0 point in by a 16th on both of those axes when you're trimming doors. And that is the only modification you need to make. Being careful with that is the only thing you need to worry about now when you're producing doors.
Very nice. Very nicely done.
Now, we've officially run an hour and a half. Do you guys have other questions? Anyone have any questions? Or you, Brandon, do you have any questions about it?
I have a lot of thoughts bouncing around in my head about different things about this.
Okay.
As is always the case, and I try so hard to shut this down inside of me because, people want help when they want help.
Sure.
And they don't want help when they don't ask for it. But I have this really bad habit of looking at everything and just kind of wondering, could it be done a little bit differently? And the thing that jumps out at me as worth exploring, let's say, and I don't have,
Sure.
I don't know that there's any good solution to this, but it scares me to think that the origin would be getting shifted on the CNC, but I don't know that there's a good solution there.
Well, the other solution would be to add kind of an L-shaped piece of material
Spacer,
at the
yeah.
origin of your machine underneath, like at where you would align it to the spoil board, or most
Right.
people align it to the pins, though.
Yeah.
So you don't really have a way to shift the pins.
You really
So
don't.
you have to shift the origin point of your CNC machine.
I mean, you really do.
So we just have a really big piece of duct tape that flips down over the monitor screen that says your offsets have been changed.
That's a good idea.
That's possibly true. Tristan said you could have a separate post for doors with the offset set in that post, but then you have to select an entirely different machine. And granted, it puts the onus on you.
Yeah.
It puts the onus on you instead of them to be right, but it's fairly simple. When you're doing doors, move your offsets a 16th of an inch in and flip down the tag that says my offsets are off.
Of course, and as is the case with anything, right? We've got all sorts of different things like this that exist in our shops. Like anybody, first of all, if you're not running a saw stop, shame on you. Go get one immediately. Shame on you.
I'm not running a saw stop. I have panel saws.
That's fine.
Sliding table saws.
That's fine. The remark is really for anybody listening. Like, anyway, like on a saw stop, you have to turn the bypass on if you are going to be cutting anything with metal, and that's a very scary thing to me because if the person that turns it off doesn't remember to turn it back on, there goes your safety. And so, right, we deal with these types of things all over the place in our shops. And so there's obviously you establish a standard practice and you enforce that very rigidly, and it's fine. And I'm sure you guys don't really have any problems at all with this. It's just a talking point, something that kind of got me thinking about it.
Yeah,
it is a big challenge.
Yeah, and Tristan's right. You'd need to select a different machine when you're outputting doors if you have a separate post. And then the other issue is if you're not comfortable editing a post yourself, you then have to pay Cabinet Vision some thousands of dollars to offset your machine a 16th of an inch.
Yes, and that is definitely not something I'd recommend most people go doing, is editing your post processor. That is a complicated area for sure. Well, thank you very much. Not that I'm like saying we're shutting this down right now or anything, but thank you for kind of walking us through this. I feel like I learned a few things for sure. I'm hoping that other people did as well.
Well, the whole idea behind this was to look at how you can incorporate a new UCS to completely go through pretty much every level of cabin vision we had. We
Yeah.
have everything from checking it in the model to optimizing it, and then incorporating a modification of a report in order to carry a parameter that didn't initially exist, uh, to keep things organized out in the shop.
Yeah, definitely.
Um, yeah, that was my goal. My goal was to show you guys that.
No, I think you've accomplished it quite nicely. Do you, so something that I think would be kind of neat, do you by chance have a link, or just like a description I could search for the door bumpers that you use? That way, I think that
Uh,
might, for anybody that doesn't fully follow like what we're talking about here, that would probably help them. I think most people do know, right? We all know what the little sticky bumpers are. You're just describing one that's mechanically fastened, but um,
yeah, 1 second. Let me there. That is the
okay,
Hayflow product.
okay, perfect. Hmm. Is it just a quick like? Do they have to like knock it in with a hammer, or is it just a press and
No, no,
click?
you can push it in with your finger.
Oh, beautiful.
The barbs hold it in relatively tight, and
Yeah,
because the force only ever squishes it in,
yeah.
it they just kind of stay in place really nicely.
Very cool. Thank you for sharing
Although
that.
that's the yeah, 8.5 by 8 by 3, and then it's a 5 millimeter press fit. Yep, that's the
Perfect.
one.
Well, I like I said, I definitely learned some things. I feel like there was some stuff that you showed that was um
Did I go over it too fast?
I don't know that you went over it too fast necessarily, but for somebody new learning it, I think that there are questions that I would have probably asked relating to like just even as familiar as I am with this, the fact that you doubled the oversize on the styles versus the rails, I'm surprised nobody asked about that because it's like I get it, right? And I understand it, but anybody who may not be familiar with doors might not have. But
Yeah,
I thought that was very that's an easy thing to bite you if you're not familiar with it. So I thought that was a
yeah.
really great point.
Hmm.
But the I'm kind of surprised we didn't get any questions on the oversizing of the styles and rails, to be completely honest. But that's okay. That's great. I think that means that the crowd we're streaming to today is either a bit more advanced,
Or a bit
or you
shyer.
did a or you okay, sure, or you did a spectacular job with this, which I think you really did. So thank you. Um, any questions, anybody? Anything? I mean, I think that this was really cool getting to see this. I always really like seeing somebody else's system.
Yeah.
It's very, very informative.
Let's unhide stuff because while we're waiting, I can brag about some stuff for a second.
Do it.
Um, I have talked somewhat extensively on the forums about a UCS that I've written that uses a comma delineation parameter to be able to assign um, operations to individual edges of parts and use different ways of machining and so on. So let's hit the back button one more time. Section modification. Let's actually just keep this simple. Left end, right end, top. Okay, there. So what we have here is just a part, right?
Mm-hmm.
And let's flip on my edge numbers, and it's edge 1, edge 2, edge 3, edge 4. So I know
Clever.
I want fastening on edge 1 and edge 3. So you just go comma 1, comma 3, and this works up to 255 edges.
Uh, why? Wow. Okay.
Because that's the limit of a while do loop.
Okay. That's a big almost circle.
Yeah. So we can select just about anything. Like here's one of my favorites for doing something in the field is these channel lock connectors, these green
Mm-hmm.
connectors. Um, and so I could just select them for an edge, and I have independent offsets per edge and quantity of them.
Very nice.
And let's go. I want 6 of them because
Yeah.
I want an ungodly amount of force to put this together. And let's say, oh no, I don't want channel locks. I want dowels instead. And see how it's preserving the quantity even though I'm changing the option. But if I change
Mm-hmm.
this to 0,
Goes your default.
it defaults it
Very
to
nice.
a set of logic. Oh, and that's another thing. I did my best to ape the logic of Cabinet Vision's Assembly Wizard,
Mm-hmm.
but for some reason, I literally cannot get these to line up. So there is some math that's happening behind the scenes in Cabinet Vision's Assembly Wizard that is
Mm-hmm.
not reproducible with the UCS.
That's really strange.
Yeah, it's very strange because it's all the same. Like I have the exact same questions filled out in the exact same way in the Assembly Wizard, and it should do dowels like this. But let's see if I can actually undelete these, depending on which variant of job parameters. But you see
Yeah.
how the middle ones are just a little bit off?
It's like a drill mask offset. Is there something wrong with the drill mask?
No, it's not a drill mask.
Ah.
It's not a fixed point.
Okay.
Yeah,
Weird.
a little bit.
Do you know what it's off by? Like, is it a
No.
consistent?
So it's a calculation of a quantity of dowel or connector or something.
I
So the
gotcha.
truncation versus the round
Okay.
or something like that.
Hmm.
And Tristan has a comment here. The method you're using to apply connectors to edges using edge numbers and commas is interesting. Yeah. So if you go to a bunch of the things that I've shared on the forums, I've talked here and there about um, something along the lines of nested part clearance edge clearances. So if I'm going to put a V bit along an edge of a part, I want edge 2 to have additional clearance. And so it'll pop up with a parameter and add this. That UCS right there is on the forums or something very similar to it. And I've hinted at multiple times that uh, that it's the kind of the precursor or the hint that you can do so much more with it because you can select individual edges of parts. And then you can calculate, front and back offsets and quantity of holes in between for a line bore, and there's a lot of different ways to go about it. But that is something that I have to let you kind of puzzle out yourself, but I'm showing you what's possible so you can maybe get curious and dig in.
Mm-hmm. That's very interesting. How long did
And sorry, go ahead.
I was just gonna say, how long did it take you to set up the different? I mean, really, I feel like most of the work for this for you had to have been with setup of the different connectors to have that many different choices. Like, man.
Um, so the hardest to set up was probably the initial one, which was the 8mm dowel.
Yeah.
After that, it was copying the 8mm dowel, modifying it to make a conformat bore, and then
Right.
modifying it again to make a 6mm bore.
That makes sense.
And the rest of this is hardware. The hardest hardware to set up was the channel lock.
Mm-hmm.
And then after that, I copied the code block for the channel lock, and I deleted the parts that I didn't need to make draw bolts.
Right.
So, I mean, I wanted draw bolts on parts that weren't countertops.
That's not a fun thing to program.
Well, it's not hard now.
No, it's not hard now.
Um,
Interesting.
But yeah, so there's my top, and I want them on the back of the part. I want them on the face of the part. I want them 3 inches in from one edge. Yeah.
Very cool.
Yeah, and then this way you can connect one cabinet to another, or if you want to take control of your countertop existence, you can add your rough top parts to a cabinet and then use this to create draw bolts,
Mm-hmm.
among other things.
Very nice. Very nice.
All
Well,
right.
I think we're probably pretty good for today. Thank you guys all for showing up. Um, I'm not gonna be able to let this go. I'm gonna come up with a way for you to program that thing and set it on the CNC without anybody having to change the offsets. I think it's possible. You kind of got me going on something here. We'll see what I come up with. I'll probably come up empty-handed, but
Take it as a personal challenge.
yeah, I really am. I think it's a very interesting problem. And
Brandon's next video: how to modify your post.
no. I'm thinking more along the lines of like just maybe nested part clearance values or
Well, the nested part
something.
clearance values only spaces parts apart in a nest,
In a nest. Yes.
so that's not going to help you there.
No, probably not. But I've got some ideas. So either way, I will probably come back to you and say you are absolutely correct. Shame on me for questioning, but it's a challenge I'm going to take on, I think. And I just want to thank you again. This was very informative, not only for the doors aspect of this, but obviously the user created standards part. I think the
Yeah.
more information we get out there about writing UCS and best practices, the better. So thank you
And
very much.
destigmatizing it.
Yeah, right?
I
It's
mean,
not
you don't need to be
magic.
a computer programmer. you
No.
you don't need to be a computer programmer. It helps, but often enough, you find that being a computer programmer before you hop into UCSs leaves you a little confused sometimes.
I think it does, really and truly. And I don't know. I still don't know what the best candidate for learning cabinet vision is, but I don't know. I think it's a weird mix, but
Oh no, you got to take anything and everything from any source you can find.
yeah. And just in general, um, to add to your point about sort of destigmatizing it, user created standards are really not evil or bad. They don't do things they're not told to unless there's a software bug, which we can't control, right? They do what you tell them to. And most of the times, I think people end up with this weird idea about them as a result of working with user created standards that were poorly written or working in a system that was broken by somebody that didn't realize they broke it or something. They're not
Yeah.
bad. They're so useful. They're so helpful. But um, I do think it's important you pick and choose. And what you're showing us is not something I think you can pick and choose with. It's a clear cut situation where UCS is the answer. And
Well, I mean, the other answer would be copying and pasting all of his operations from door to door to door to door to door to door.
who's going to be in business doing that?
I've seen it.
I suppose, right? But
Yeah.
at the end of the day, right, that's not a practical or sustainable business practice,
Yeah.
you know?
No, anything that's a repetitive process that can be automated is something that you want in a UCS.
Definitely. So David is obviously the one who knows most about this, but if you guys do have any questions, obviously post them up on the forums or when I get the YouTube video uploaded, which will
Or if you
be
guys are here from the
soon.
cabinetry subreddit, you can ask them on that thread that I posted.
Yeah, definitely there too. So and let's get an additional kind of conversation going about this if there's one to be had. Otherwise, I think that means that you did a really great job of explaining and just thank you again.
Yeah.
And
You're
thank
welcome. It was a blast. Can't happen all the time, but it was fun.
no, I agree. So thank you guys all for showing up. Thank you, David, and I hope you guys have a really nice weekend. Take care.